Hey, we're here a little bit early. Can you hear me okay?
Yes, I can hear you.
Okay, great. Yeah, so that you're up for presentation today.
Okay.
Just give people a couple minutes to join. We're still a little bit early.
Hi, folks.
Hi.
Hey, how's it going?
Pretty good, thank you.
Yeah, I guess while we give people another minute to join, we need topics other than the ones listed in the minutes you want to talk about? No, okay. I think we could probably go ahead and get started. Looks like we have a couple of presenters today, about looks like about 35 minutes worth scheduled. So if there's nothing else to add to the topics, maybe just go ahead and get started. I think Peter, you had some presentation that you wanted to give today.
Yeah, okay. I can share my screen right away. Is that okay?
Yeah, it's great. Thanks.
Can you see my screen?
Yes.
Okay, so can I start or should we wait a little more?
I think you're good to start. We got pretty good quorum. We got 15 people.
Okay, I suppose I can start. Hello everyone. Thank you for having me. My name is Petar Paradžić, and I'm gonna give you a short introduction to a paper that we recently submitted. So the paper is titled titled Formal Security Analysis of the AMD SCV SNP Software Interface. And it was a joint work with two other gentlemen, so Ante Jerenk and Marko Horvat. So in this work, what we did is we analyzed one particular trusted execution environment that is called AMD SCV SNP. I suppose that most of you have already heard about it, but in case you didn't, I'm going to give you a short overview of it. And then I'm going to give you an even shorter overview of the tool that we use to analyze this particular trusted execution environment. And in the end, I will talk about our model security properties that we analyzed and results that we obtained. Okay, so what is AMD SCV SNP? What is AMD SCV? So AMD SCV is a family of T technologies designed to protect virtual machines from malicious hypervisors. So they are available for AMD's EPIC brand of microprocessors that are targeted for server embedded markets. So over the years, AMD introduced several such technologies, beginning from the secure encrypted virtualization that came out in 2017. It was then based on Zen microarchitecture, codenamed Naples. And basically, among the standard T features, such as remote attestation and hardware accelerated memory encryption, like this T also has a couple of useful features. Like, for example, secure swap. It can be used by a hypervisor to move encrypted memory page from a system memory to some offline storage medium like disk. And also, like, we have a live migration, a mechanism that can be used to transfer a guest to another physical system, to another platform without interruption for the purposes like load balancing and host maintenance and so on. So the next technology is the SCV encrypted state. Like, it basically aids the capability to encrypt integrity, protect contents of registers that can contain information about the VM runtime state. Now, this is important when the VM wants to transition control to a hypervisor, and then a hypervisor could otherwise attempt to read and write such registers and like execute some form of a rollback attack. And most recently, we have like secure nested paging. So this technology will be our focus today. Some more about it on the next slide. But I want to mention that all of these technologies are basically implemented as a piece of a firmware running on AMD security processor. And this AMD security processor is basically an isolated ARM core that runs independently of the main x86 core. And this firmware implements some application binary interface. And this interface is intended for a hypervisor to use. And hypervisor can use this interface to enable all of these features that I mentioned before. Okay. So AMD Secure Nested Paging is a complete overhaul in a sense that provides completely new software interface that is not interoperable with the previous one. And now the novelty here is that one of the novelties is that it provides SNP protected guests with a secure communication channel, and SNP protected guests can use that secure communication channel to communicate with the SNP firmware and request various kinds of services. Like this way, SNP protected guests can request and obtain attestation reports during the runtime. Now, this was not possible in the previous SCV technologies, because in the previous SCV technology, the only attestation was launch attestation, and consequentially, the only third party that could attest a guest during the launch was the guest owner. So this SNP also enforces different security guarantees regarding the live migration. So in previous SCV technologies, firmware on the source machine was responsible for authenticating the firmware on the destination machine. But now in SNP, this is offloaded to another entity that is called migration agent. So migration agent is another virtual machine, another SNP protected guest, and its purpose is to enforce guest migration policy. And also, like SNP, AMD emphasizes a lot this software integrity protection, memory integrity protection. And this integrity protection, among other things, is described in the next white paper. So this is the white paper of the SNP. It came out in 2020. And in that white paper, you can find a list of security guarantees that AMD specified. And you can also find a threat model. And like regarding this threat model, like from the point of view of a guest owner, the only trusted components are his or she's S&P protected VM and AMD firmware that's running on the AMD security processor. Okay, all other components, including a hypervisor and also other S&P protected VMs. So all other components are treated as untrusted. And regarding these security guarantees, like you can find like integrity guarantees in this list. And basically, S&P can basically detect when a hypervisor wants to manipulate page tables of a guest. For example, S&P can detect an attack when a hypervisor wants to map two different guest physical addresses to the same system physical address. And also like the opposite, like when a hypervisor attempts to map a single guest physical address to a multiple DRAM pages or system physical addresses. So like basically this S&P like ensures one-to-one mapping between system physical addresses and guest physical addresses. Okay, now that's great, but it is not like we are not very interested in verifying these security guarantees. We assume that all of them hold. We are more interested in what kind of security properties are provided to those that use this software interface. Okay, so we are more interested in the following document. Okay, so this is the official specification of the S&P software interface. And in this specification, you can find a list of instructions. Okay, and this list of instructions are intended for not only for a hypervisor to use, but also for a S&P protected guest. So as I said previously, like S&P protected guest has a secure communication channel by which it can communicate to S&P firmware. And S&P protected guest can request various kinds of services through this channel. And like on this channel, like hypervisor is not only eavesdropping, but it is actively carrying messages. So hypervisor is basically a message carrier here. And we are very much interested in this communication channel. And basically what we are interested in, what kind of security properties are provided to those that interact with this software interface. And I want to emphasize that AMD didn't specify these security properties here, okay? And also, like related to that, can the adversary use the software interface in such a way that the system reaches some undesirable state? Okay, so these are the main research questions. And now, our model in a nutshell. So to the best of our knowledge, this is the first formal treatment of AMD SCV S&P. And again, we are not interested in the implementation of a T. We assume that all of these security guarantees that AMD specify in the white paper hold, but we are more interested in what kind of security properties are provided to those that use this software interface. So our model is fairly large. It has almost 6,000 lines of code. We have specified and analyzed over 19 security properties, and among those, there are 36 security properties. And we have found four so-called platform confusion attacks. I will try to explain you these attacks in the end, some of these attacks in the end. And this paper is currently submitted to a journal, and the preprint is available if you're interested in. Okay, now let me give you a short introduction to the tool that we use to analyze this software interface. So the tool is called Tamarin Prover. So Tamarin Prover is a semi-automated security protocol verification tool in symbolic model. So in Tamarin, so in the best case scenario, when you model a protocol and specify a property, you would push a button and Tamarin would tell you whether that model satisfies the property. But unfortunately, this only holds for very simple models. So most of the time you have to guide the proof somehow. And Tamarin has many useful features. I will mention a few. Like it's capable of verifying protocol in unbounded number of sessions. It has a wide variety of built-in cryptographic primitives. And here I want to emphasize that it is capable to model, it is possible to model monotonic counters in Tamarin. Now, this was very helpful to us because we wanted to model Galois counter mode encryption in Tamarin, and we needed to somehow to model nonces. So we implemented basically nonces and monotonic counters in Tamarin, okay? And then also one useful feature is that Tamarin can handle protocols with mutable global state. that is also very, very useful because it enables us to model like swapping, because in swapping, basically in our model, like state of the guest that basically pops in and out of the global state of the existence. And also Tamarin supports like proof by induction. And this is also very, very helpful because again, each of our entity can execute indefinitely. And we needed some kind of a proof method to reason about that kind of behaviors. And also like Tamarin is very, very popular term among ProVerif, with ProVerif, like, and this is also a big plus. Okay, so our model includes like remote attestation, main features like remote attestation, key derivation, page swap, and live migration. Again, we model 4 entities. Those are like S&P protected guest, S&P firmware, migration agent, and a guest owner. And we allow unbounded number of threads for each of those entities. And as I said previously, we also support, like, we also model Galois counter mode of encryption. And we have basically implemented nonsense and monotonic counters in Tamarin. And basically, we have analyzed 96 security properties. Among those, not security, but properties in total. And among those properties, there are 36 security properties. So those are secrecy, authentication, attestation, and freshness properties. And we also have these supporting properties, a large number of supporting properties. So these are also called like helper lemmas in Tamarin. So basically, the purpose of these supporting properties is to ensure termination or to improve verification time. Okay, so basically, and the whole analysis like took I think some 8 hours or so 480 minutes in total. Okay, so we model 4 entities, as I said previously, and our model can be described in terms of these interacting state machines. So we have 2 state machines for the S&P protected firmware, and we have 1 state machine for the guest owner, 1 state machine for the S&P protected guest, and 1 state machine for a migration agent. And each of these state machines can be copied unbounded number of times. Okay. And moreover, like each of these state machines like supports a kind of unbounded execution. Like if you take here, for example, this state machine that described S&P protected guest, then this S&P protected guest can request and obtain unbounded number of it can request unbounded number of key derivation requests and also report attestation. It can request then in any order unbounded number of times. Okay, so we support a kind of this unbounded execution, and as I said previously, we needed induction to reason about this kind of behaviors. Okay, so this like concurrently executing all of these state machine, like you can exhibit some complex behavior in Tamarin. Okay, so like this is the most difficult thing that we this turned out to be the most difficult thing to prove. Like basically we wanted Galois counter mode of encryption is used heavily inside S&P, so it is used all over the place. And we wanted to like prove whether it is used correctly, whether it is utilized correctly. And what does it mean to utilize like GCM correctly? Well, in this case, it means that the same key is not repeated with the same nonce more than once. Okay, like, and to prove this property here, like we needed we specified over 40 supporting lemmas for this property alone. Also, like S&P has very complex key dependencies. Like as I said previously, like proving secrecy properties also turn out to be quite difficult because this S&P has very complex key dependencies. Like take for example the secrecy of a derived key. So as I said previously, like in S&P, S&P protected guest has a secure communication channel by which it can request for various services. It can request various kinds of services, And among other things, like one of the things it can request is it can request for keys to be derived by the firmware. Okay, so firmware can derive keys to the guest, and this is the lemma that specifies the secrecy of such derived key. Okay, and this like secrecy of a derived key depends on the 5 other keys. Okay. Now, why is that? But basically, like if we compromise the key that is used to derive other keys, then we basically compromise the derived key. So the adversary can also compromise a secure communication channel that between the SMP protected guest and the SMP firmware. So the adversary can also compromise like pages of a guest during the like which are encrypted pages of a guest that are encrypted during the swap. And also, adversary can compromise secure communication channel now between migration agent and SMP protected firmware. Okay, so there is a lot of ways by which you can get to this derived key. Okay, and also, so this property right here is called weak attestation report integrity. So this property says the following. So if the guest owner verifies the report, okay, and if the report says that the guest with the image ID is executing, okay, among other things, and if some things are set additionally, like if the migration is enabled, then indeed holds that sometime before SMP protected guest indeed requested this attestation report. So this was the guest with the correct image ID, and this guest was executing on some platform like chip ID. Okay. And otherwise, so one of these keys is corrupted. Again, you can see like complex key dependencies, like even this property. And this property also holds, but a variant of this property doesn't hold. Okay. Okay, so what kind of properties doesn't hold? Okay, so we have verified 36 security properties. So secrecy, authentication, attestation, and freshness properties, and most of them hold. But 4 authentication properties and 1 attestation properties does not hold. So okay, so this property doesn't hold. Okay, so this property says the following. So if the firmware receives the attestation report, okay, if the firmware receives the attestation report, while it is executing on the platform with chip ID, okay, then it must be the case that at some time previously, the SMP protected guest that was executing on this same platform with the same chip ID requested it as attestation report. Okay, but now this property doesn't hold because this guest, it could be the case that the guest is executing on some other platform because the migration is enabled again. Okay, guest can be migrated to another platform. So what can happen here? I mean, so take a look at this, consider this diagram right here. So the sequence diagram, so guest requests an attestation report right here, okay. And then the adversary blocks this attestation report, okay. And then the adversary migrates guest to another platform, okay. It migrates guest to another platform, and then guest okay, it transfers guest context to another platform, and when the guest context is installed on that another platform, like the firmware starts executing on that another platform, the firmware starts executing, okay, and the firmware on another platform will happily accept this request, okay, from the guest, even though this request is not from this platform right here, but this request originates from the previous platform, okay? So basically what the adversary did here is that he just routed this message to another platform, okay? And then because of this, accept request, like this property doesn't hold, okay? And it can also be, because of the property before doesn't hold, also this property doesn't hold, and this is similar to the previous property that I described to you. This is now like strong attestation report integrity, And what is different from the previous property, like here, like when the guest owner verifies report, okay, and the report says that the guest with the image ID requested this report while it was executing on the platform with chip ID, okay. But now here, like guest was not necessarily executing on the same platform with the same chip ID. Okay, it was executing on the previous platform. Okay, so because of this chip ID, this chip ID, this term right here doesn't have to match, and because of that, this property doesn't hold. Okay, so that would be all from me. Like, if you're interested in, like, this paper is submitted currently to a journal, but the preprint is also available. And if you're interested, the model is also available, and you can ask me any question if you like. So thank you very much.
Hey, thanks, Peter. We have a couple questions in the chat. If there's any other questions also?
For the request on an old platform after migration, is that an attackable surface? What is your understanding of that property that failed to hold?
Sorry, I didn't hear you very well. Can you repeat the question, please?
The property that failed to hold through migration. Did you find a way to attack that weakness, or is that just a?
Sorry, what kind of weakness are we talking about here? What kind of property? Is this property right here, or?
Mm-hmm. Is there any information you can glean from this this weakness to accept the request that comes from an old platform?
Unfortunately, like, okay, we didn't find any such like weaknesses. I mean, like this property right here, like, okay, so we don't have like weak agreement right here. Okay, we don't have weak agreement, but it isn't the case that the adversary could put anything that it wants in this message right here. I mean, it is just routed from one platform to the other. So again, I don't think that this is any like has any serious consequences, as I'm like I don't know. We haven't found any serious consequences regarding this. So
maybe I can elaborate a little bit more. This is Ante, one of the authors on this paper. So one part of the question, did we try to actually turn this into an attack? The answer is no. We didn't have hardware available or the necessary expertise to play with it. So that's why we call it attack in quotations in the paper. It's an attack on a formal model, but we have yet to verify that we can launch these attacks on the actual hardware. And actually, we're looking for collaborators to help us verify this on the actual hardware. If you're interested in that, or you know someone who would be interested in that, please contact either me or Petar directly. And then furthermore, we write about this a little bit in the paper. Even if the attack exists, we are unsure if the impact is huge. Essentially, if you really care about your software running on a particular chip, then you will disable migration. What the attack basically emphasizes, if you launch your guest VM in such a way that migration is allowed, then all you are guaranteed is that if you verify an attestation report, this thing was at some point executing at some AMD platform. Does that answer your question?
Enough. I wasn't aware that you could use the same VMPCK across migration. But
Diana, this is Jeremy Powell. I'm the actual author of the ABI for S&P. And so I think I can talk a little bit to this if that's what folks would like to do.
I would love to hear more from you.
Yeah, so I follow what you're saying, right? You can just basically freeze the guest, it gets migrated, bring it back up, and then you kind of split that report request between the two. The ABI is designed in such a way that, you know, if let's say you're using the migration agent has to be part of the migration action. So what that means is that before what that means is that basically part of the guest TCB is choosing explicitly to migrate to another platform. And that has to happen before the guest context is exported and sent off to the other side. So yes, the guest could be part of this, you know, it could be frozen in the middle of this, like the rich guest, but the orchestration software around the guest that's part of the TCB has to approve that the destination machine is acceptable to that guest. And so we basically require the guest, I mean, we don't require it, the guest should check that the attestation is of the destination machine is okay before allowing the transition. And then we have a model for a guest that wants to be migrated without a migration agent for certain CSPs that don't want to do that. And that's basically giving the guest the ability to export that it's a guest a context in a way, and it itself still needs to go push forward at the, you know, it has to go say I trust the destination machine before it ever sends the exported context out to the new machine. So there's definitely what you're seeing here, I think, is absolutely true as part of the model you've defined. But I think what the model doesn't capture is the expected software checks that have to happen before attestation should move forward. I'm sorry, before migration should move forward.
Migration, yes. Yes, I agree with that assessment. As I mentioned before, we are kind of looking forward to trying to explore this further, playing with the actual hardware and coming up with potential scenarios where this could be a weakness, or, you know, failing to find potential scenarios where this could be a weakness, or proving that they don't exist. That's also a good outcome. But to actually answer the previous question, yes, VMPCK is migrated along with the guest. And in fact, the problems stem from exactly the fact that you have to do this in order to make the migration seamless. So guest can issue a SMP guest request, and, you know, at the next assembly instruction, just as it sent this guest request, it could be migrated to a completely different machine in a state where it's waiting for the response to this guest request. So if VMPCK was different, then you would have to do things differently. You would have to account for the fact that sometimes you would send a request, and because you're migrated, you're not going to get a report that you can decrypt and somehow work around that. We also considered suggesting some fixes along those lines. We debate this a little bit in the paper. But yeah, I completely agree that it seems to be necessary to do it this way if you want migration to be completely seamless and transparent to the guests. And I agree that if you account for additional logic inside the migration agent, you can mitigate some of these attacks using that logic.
Yeah, I think this
However,
definitely
I do need to highlight that this logic is not part of the specification. The specification doesn't tell you how to write a good migration agent.
That's right. Yeah.
And this
I
is
mean,
something we wanted to explore in our model as well. Like, can you write a reasonably looking migration agent that's actually not good? It doesn't give you good security properties.
but yeah, I mean, I think
So
that's
yeah, there's
that's
plenty of
definitely-
avenues we want to explore.
It's definitely a fair thing. It would be, we have left a lot of that decision making up to the consumers, like the hypervisor vendors, to figure out how migration would work, and then have guests, talk. Guest image vendors add that to their guests, like in the Linux ecosystem. So that is interesting. I know that we have short time here, but could I get an email so that we could discuss this? I'm not sure. Have you guys mentioned this paper to AMD yet? Like officially?
No, and our motivation for coming here to this forum was exactly to connect with someone from AMD. So I'm very, very glad you're here.
Okay, could I get a contact information from you?
Sure. Our emails are on the paper, and the link to the paper is in the comments, but I'm going to put my email in the comments right now.
Great, thank you.
Yeah, in the meantime, just I would like to just add a little bit of that. What Ante said, in addition to that, I think even if something is not specified, it's still very important to actually analyze that, because people can use it in very, very different ways. And if some of the ways lead to an attack, that's really something needs to be specified. So the missing specification, the general consensus in the security as well as the formal community, I think, is that everything should be precisely specified. If it is unspecified, any possible implementation which leads to an attack is an actual attack.
Yeah, I think that's a fair point. And I know, Mohammed, you've done some research on Intel SGX and the unspecified parts of the attestation process in both SGX and TDX. And I agree. And especially for the migration agent, which is security sensitive, I don't think it needs to be specified in full, because you want to leave the flexibility to the vendors to do it in a way that's best suited for their infrastructure. But I think some minimum sanity checks should be specified. And then ideally, our job would be to say mathematically, if your migration agent satisfies these very precise mathematical properties, then the system as a whole, ABI plus a reasonable VM plus a reasonable guest owner plus a reasonable migration agent, gives you this high level properties, attestation, integrity, freshness, and so on.
Yeah, sure. So yeah, I don't mean to absolutely precisely specify everything, leaving out some details, but at a minimal level, as you said, I completely agree with that.
Hi.
One related question.
Sorry.
Oh,
Yeah.
sorry.
No, that's fine. Please finish.
Just
No problem.
Just a quick question. So the property that you mentioned for attestation, that is, so do I understand it correctly? It's only when you have migration enabled. Is it correct?
Yes, that's correct. Yes.
Okay. And so what is the kind of the algorithm or the protocol that the two parties use? Do you just use the like the, as you call it, request response, or do you also use some kind of protocol level? Do you have a protocol level layer like TLS or something like that on top of that?
You mean in the
So
SMP?
between the, yeah. Does
they
the
use the
protocol
ad
specify
hoc.
which protocol do they use?
They use this ad hoc mechanism where you essentially have a shared secret between the VM and the security processor, and they encrypt and integrity protect messages using AES GCM, and then the counter is also used to prevent replay attacks, and those encrypted messages are then routed via the hypervisor, from the guest VM to the security processor and back.
Right, thanks.
Cool. So I've got a question which isn't directly related to attestation, but is related to the this possible vulnerability, because vulnerabilities are only relevant where there are attacks to some degree, as we've kind of discussed. And the question is, how much are we seeing migration being used in the wild? And I can think of 2 use cases for migration, main ones, and I'd love to know if there are others. The first one is the owner of a VM deciding to migrate to another platform because they feel that's the right thing to do, and whatever that may be, maybe for freshness or for network access or whatever. And the second is for infrastructure reasons. So the infrastructure owner decides they want to migrate VMs because they want to shut things down, or they've got resource issues. And I'd love to know, firstly, whether anyone in the room is aware of either of those actually being used. Well, no, I kind of guess that's the question, really. Do we have any people are actually using migration, and for what? So I'd love to hear people's thoughts on that.
I would love to hear this as well, but I have no idea.
I'll speak up. So I was involved for quite a few years in Microsoft Azure data center management, data center health. And a key functionality that you need to do is when you're doing infrastructure upgrades. So say AMD SCV publishes a patch, and we say, okay, we need to update all our hardware to incorporate this patch. And we have our customers' VMs, and they didn't sign up for interruptions due to us deciding to take hardware down. And this happens like all the time. So we and this is a hyperscaler. Yeah. So we're talking, hundreds of thousands of virtual machines. So the process of updating hardware is you live migrate all your workloads to other hardware that's presumably already upgraded. And then you take that hardware down for an update, for reboot, whatever. So there is, it's absolutely critical for confidential computing adoption to be able to do migration in a data center, live migration.
Well, that assumes. So I think there's a question there, which is that you might say that because there may be perceived vulnerabilities, you might say if you're using confidential computing, you may want to design your application in such a way that migration is explicitly not allowed, and that there are alternatives in terms of failover. I don't know whether that makes sense or not, but it might be something you want to do.
I would say it's not an option. So if I have a portion of my data center that needs to be upgraded with customers' workloads on them, some of which are confidential, it is an absolute requirement to be able to live migrate those workloads as part of data center management. Period. Full stop.
Okay, that makes. So you would never consider saying to a customer, look, we're not going to live migrate these because they're confidential workloads, and you need to architect your solution around that. That makes sense.
Correct.
I understand that. Okay, Thank you. Anyone else? Fritz, you have a question. I don't know if it's related to this, but.
No, it's not related to this. So this is more a question to the broader work in the paper. It's always nice to see tamarin work in the wild, and some research being done with tamarin. So I have a question a little bit to the model. So I mean, seeing your runtimes and the size of the model, there's always some corners you have to cut, right? There's always some limitations and restrictions you have to put in place, which can sometimes be overly limiting, right? So I just wanted to, maybe like an open question, ask about what limitations did you put in, like only once, for example, I don't know, only ever have one root key or things like that, right? And which of these might have an impact, but were just being put in due to performance reasons. So I think this is more of like a tamarin and modeling question, how close you can actually, or how close you did actually get to the truth of the specification.
Okay. So yeah, we have several, like our model, you can find in a paper like limitation of our model, all of the limitations. And so one of the limitation is that we allow for only one migration. Okay, so for only one migration is allowed from the source platform to the destination platform. Another limitation is that like I mentioned that we model our AES Galois counter mode of encryption, AES GCM mode, but it is only for guest messages, okay? So those are messages exchanged between S&P protected guest and the S&P firmware, and also migration agent and S&P firmware, okay? But we don't model Galois counter mode of encryption to encrypt to encrypt pages while the guest is being swapped, okay? This is like one of the limitations that we put because of the complexity. And we use standard encryption in the model when we swap a guest, okay? And we don't use GCM there, even though GCM is used in the specification, okay?
Yeah, I think that's normal, right? Because you just use whatever Xamarin supports, but only one migration. Did you play around with maybe allowing two? Because they could either leave or you could do some switcheroo text or something like that? Or did you just
No.
play it with one? Okay.
Yeah, I mean, the model was already really now, like it takes us 8 hours to verify everything. Now, if I put one more migration, like, I don't know. Yeah, I mean, I think that it will because of the things like state space explosion. I mean, I didn't
it will
play
explode in your face, of course.
with more than one migration now. So
yeah, and beefier machines only help so much. I remember we had like a 80 core, 90 core machine at some point, and even that took like hours and hours. So yeah, that easily explodes. But just always interesting to hear what restrictions you put in place, because these can always mess something up, right? But it's thanks for the.
As I said, you can find a detailed list of limitation in our paper. Like so.
Yeah, I'll check it out. Thanks.
Yeah.
But you're absolutely right. Like from my viewpoint, Petar is the one writing the actual model, and you're always dancing on the border of what's feasible. Like you add stuff, then it becomes impossible to verify. Then you're looking for tricks, shortcuts, lemmas, and so on, or you're looking for simplifications and further abstractions. And then at some point you have to say, well, okay, now we're happy with the level of abstraction and with the results that we get. But you're absolutely right in the sense that we have to make some hard choices and give up on the stuff that we would love to model, but we are just unable to.
Yeah, that's totally normal. I know the pain.
Okay, hey, thanks for the discussion. It's good. Appreciate it, Petar. And we do have to time check. We have about 15 minutes left, 14 minutes left. There's other topics to discuss. Are we okay to move on? Yeah, okay. Osama, I see that you have 2 topics here. Probably take the rest of the time. You want to go ahead and start?
Yeah, sure. So first thing is, I think shouldn't be hard to discuss. So we had this project back then, I think a couple of years back. We had the vision of doing the formal verification of SGX, TDX, ARM, CCK, and AMD, SEB, SNP. And I think this nice work from Peter and Ante actually completes that picture of the whole framework, and all the 3 are now, so their artifacts are also available online, and their paper is available as well. So I would like to have, I don't know what's the procedure for doing it, but I just wanted to, it's been 6 months, I haven't heard any issues on the artifacts or anything related to that. So I would like to call it a successful project. So if someone has any issues, he can raise it.
That's nice and quiet. Doesn't sound like there's anyone.
Maybe the question is rather, do we want to retire it, or do we want to keep it open in case some other technologies come up in the future and we also want to look at them, right? So do we then open new projects, or do we picks this up again? That I think that's more like a organizational question, how we want to handle it, right?
Yeah, I think the scope actually now covers the variety of things that we have seen, like migration part which we didn't do in our work. They have completed that kind of picture. And the major technologies which we had in the scope for the beginning, I think are very much covered. And just as a reference, so from ARM guys, I think Thomas will second me, and Yogesh is also here. So whatever we had from ARM, all the specifications have been modeled. And from Intel, whatever we get, clarifications, whatever we could get, we have actually tried to model it. If you go to the webpage of the project, there are a couple of discussions there. So we tried to get some more information from Intel about a few things that were unclear. I can share the screen quickly just to show you, but we didn't get the response for that. So it's been a long time, and of course we cannot keep waiting for that. And I think the answer was that they are not going to share the specifications, if I remember correctly. Let me quickly check that.
I think there are two questions to disentangle here. So I mean, it's the scope as initially conceived was very precise, right? And I think it makes sense to wrap up now that we have covered what we started and we said initially we would do. There is a secondary question here, is whether we need to track these specs or not, because ARM CCA is evolving, so there might be updates to be made as we go. Question is whether we want to keep this potential work within the scope of this issue or not. I'm not sure about this answer.
Yeah, that was more the question exactly. So more like organizational. Do you want to kind of close it now and kind of reopen it later if you see changes, or do you want to keep it open? It was more question to you folks, right? Like I don't mind how you want to handle it.
Yeah, it sounds like a good point, right? So we might as well close it now and stating precisely which version of the spec we've modeled and we have results for, and then maybe reopen in the future if you see the opportunity to do so, either because the technology evolves or because we want to cover more technologies.
Yeah, fair enough. Maybe then just let's put a marker on what version of the specs were the ones that were locked in, right? Just so that we can look at it later again.
Sounds like a good idea. Usama, you're going to take care of that?
Yeah, sure. I think we already specify. I will make sure that I will just double check that it's in the main page. It's there specified.
Yeah, very visible. Thanks.
Yeah. Okay. And then I think I will just give a quick overview of the other thing, which was basically status update on the ongoing project on the basically the attested TLS. And it's the same team which has done the same work for the ARM CCA and Intel TDX verification. So basically, I wanted to share a high-level idea of what we are currently doing and what's the current update. Platform level attestation, what we mean by that is that we have different platforms at which different roles are being distributed. So it's not any specific technology, it can be any technology. And the assumption here is that this application or the service, which is shown here on platform 1, is not this. So there could be that this attestation service is on the same platform as this application service. So the assumption here is that it's running on a different platform. So clear distinction between the two. And then there is this CLI, which is interacting with the attestation service. And so this is the kind of the application owner, which is again at a different platform. And the fourth one, which is the configuration and application, configuration and attestation service owner. And this is the attestation service or the configuration and attestation service in very generic terms. So this is assumed to be on a different platform as the platform on which the attestation service is running. So what I show here is basically three different stages, as we call it, of attestation, which is happening. The first one is the CAS owner will attest that the attestation service is correct and then pass on the configuration of the CAS. So basically then in this case, this attestation service or CAS is acting as the attester and CLI is acting as the verifier. And then in the second stage, and after successful verification, it will pass on this configuration. Similarly, in this case, and on the top of the arrows, you see the TLS roles. That is, this entity will act as the server and this entity will act as the client. Because we are talking about attested TLS, so this is the TLS terminology. And from the second stage, what we have is CLI as the client and attestation service again as the server. And after successful attestation, it will pass on security policy. And the third stage is the typical one, which we always hear about, is that the application and the platform or the attestation service is basically doing the attestation. And afterwards, after successful attestation, it will pass on the configuration or the secrets. So in this specific case, so just like in the KBS, so this is acting like the KBS server, and it will pass on the configurations or the secrets to the application or the service acting as the client. So this is the high level picture, and it's a work in progress, which we are trying to generalize across all solutions rather than having some specific solution. It does use some SCORN terminology, which is why I had the title, but it can be, so this is, here I'm just using it generally as configuration and attestation, both are embedded within. And feel free to interrupt if you have any thoughts or comments in between. I would.
Hey, Osama.
Yeah.
You invited the interrupt, and I was actually just thinking of a question.
Yeah, sure, please.
I'm staring at this, and I'm thinking about the RATS architecture diagram, and just wondering how this maps to that, because it seems possible security policy perhaps is some sort of one of the policy providers or verifier or what have you. So is it possible to recast that using RATS architecture terminology, or do we have to go? Yeah,
so exactly, I
okay.
have it here. So at a very high level, so this platform 1 will be the attester. So platform 2 will be the verifier, and platform 3 will be the relying party. So this is the details here are SCORN specific as compared to that slide. But this was generally the idea that the platform 1, 2, 3 are respectively the attester, verifier, and the relying party.
But like some of the parts, like where the policy is coming in, does that map to like endorsements or reference values or attestation results policy? Or, there's some parts in that diagram that were finer granularity.
Yeah, so we have in, sure. We have in a lot of detail, like for each stage, who exactly is the reference value provider. For instance, in stage 2, like sContain is acting as the reference value provider. So we kind of provide in the SOK paper that's been already, the preprint has been there already for 1 year, I think. We were waiting and waiting and waiting for SCORN to provide us the missing information. It's a non-ending loop. So what we do is basically we are trying to generalize what is the missing information, and specifically about your question, who is acting as compared to the RATS roles. We define precisely in diagrams like this that the dotted lines are representing the RATS role, and the entity inside that, the rectangle, is acting as which entity is basically this taking up this role. For example, the app owner in this case is the verifier owner, and so on. This is the remote verifying relying party. And the remote evidence is the part coming from the other stage. So we have
And correct me if I'm wrong, but I suspect is there also do we need to think of it as applying the RATS diagram n times because things shift around? Like,
yeah.
turn the crank once and these folks are taking these roles, turn the crank again, these same folks are taking slightly different roles. Is that also happening here or?
Yeah, exactly.
Yeah.
So that's my long-term complaint with the RATS architecture, which is that I never need to use, let's say, so it's kind of recursive, as you said. So in platform 1 and 2, what we are seeing is basically, or let's say start with the stage 3. So app is acting as the attester, and this is acting as the verifier. Now this is acting as the attester in stage 2, and this is acting as the verifier. So this is acting now. Sorry, this one again in the first one as the attester, and this is the verifier. So this is kind of still doing the same thing. So yeah, because for TLS, there are only two roles like client and server. And specifically in this work, then we decided that we take a specific role that the client as the attester, and then generalize the protocol across all the three, meaning the pre, intra, and post handshake attestations. We describe what are the design choices that a user has or a protocol designer actually has for doing the kind of attested TLS protocols. So yeah, does that answer your question?
Yeah, it goes some distance towards answering. Thank you.
Okay. Any other thoughts? I think
Yeah, just a time check right at the top of the hour.
right. Any quick comments before we close?
So should we continue this in 2 weeks, Osama, or do you feel like this is the coverage you wanted, or?
So yeah, I can quickly just I need to check the schedule. Yeah, in 2 weeks I can cover like I think I will need 10-15 minutes for this.
That sounds reasonable. I don't, Jim, do you see? I didn't see anything on the agenda for 2 weeks out.
Mhm.
No,
Is
I
that
certainly
accurate,
didn't see-
Jim?
Yeah, I didn't see anything.
Yeah.
So we can add this for sure.
Thomas, are you aware of anything 2 weeks out?
No, I have no things in the backlog, unless we want to go through the issue tracker and try and engage with anyone. But no, at this point in time, I don't.
All right. So Sam, I think if you're willing to come back in 2 weeks and continue it, I don't feel like we've covered this topic.
Yeah, sure. So I will
completely,
make some more slides, and we have this preprint in which we did all the mapping to the RATS roles. If there is something else which is interesting, please let us know, and then I will try to cover that.
Right.
Thanks a lot.
So it sounds like next week or 2 weeks out, the tentative agenda is a continuation of this discussion, plus potentially go through the issues and the existing issues and just kind of review them and see what folks have to say and add, et cetera.
Yeah.
Yeah,
All
sounds
right.
good. I think the
There's-
other clerical
I
part
would-
is picking our next chairman,
Pardon me?
the chair for the next meeting.
I think
yeah,
it'll
the
naturally
problem-
be Keith, but he's not here today, so I think I'll be next in the order.
Oh, thank you, because I won't be here. I'm on holiday for the next 2
Yeah.
weeks. So
Yeah, I
Okay.
can cover a couple weeks.
thanks, Greg.
Okay, yeah.
Thanks very much.
One quick question,
Yeah.
or maybe I'd do it offline, but there was some interest in the Whimsy, I call it Whimsy, I don't know how everybody else pronounces it.
Yeah.
Does anybody have any contacts, or is there some, to me, I'd love to have, if we could get somebody from there to present a brain dump of kind of what's happening would be fantastic, but
Yeah,
don't.
yeah, I can talk to Yaron and see if he's available for a chat here.
Yeah, that would be, I would be highly interested. I suspect lots of folks would, I think.
Yeah, Ines as well is a good one. But yeah, I can ask them and see if they want to.
And maybe
come
he
here.
could if you have the I think you probably have the best context. If you could start the legwork of socializing, maybe getting somebody to consider coming over and kind of giving a brain dump of what's happening there.
Sure. Yeah.
All right,
Awesome.
great.
Thanks
How long are
very
you on
much.
holiday, Thomas? You gone for just one session or multiple?
2 weeks, so only
Okay.
one.
Okay. All right. Good.
Cheers.
Yeah.
Okay.
Thanks
Thanks
everybody for
all.
joining.
Bye.
So
Thank
take care.
you.
Bye.
Bye-bye.
Bye.
Bye.
Thank you. Bye.